Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So tonight's topic is hybrid and EV diagnosis and repair. So we're going to talk about similarities, differences between the two. And it's been a little while since we've talked about hybrids or EVs in general. It's been a couple years, so we're just going to kind of give you a nice overview of kind of the state of where we're at here. So first off, we're going to start with electric vehicles. Now, electric vehicles, basically, it's a rolling battery with an electric motor on it, if you want to think about it, because those batteries are pretty huge. On some vehicles, they can be structural members of the vehicle as well, like underneath. It takes up a lot of space. Very large, very heavy. We're going to talk about that in a little bit. Now, you notice this motor kind of looks like an internal combustion engine in this particular picture, and it depends on the manufacturer. Some manufacturers, if they also produce vehicles with gasoline or diesel engines, they will make the electric motor fit the same hole as the electric or diesel engine. So, for example, like a Hyundai Kona, you can get two different engine options, internal combustion engine options and an electric option. So they just have them all similar motor mounts. They can just plop them in there and go. So as far as components on an EV, the main components, of course, are the battery, like we talked about. And of course, we need a battery cooling or heating system because the batteries can get warm. And then if it's cold out, they need to be warmed up. So we have a cooling or a heating system. Oftentimes they'll just utilize that with a antifreeze coolant type thing. Voltage converter, we need to convert high voltage to 12 volts and so on. Sometimes we need to convert what's coming out of the battery a little bit before it gets to the motor as well. Regenerative braking system, that's going to help charge the battery when we're in coast or in where we apply the brakes and so on. Electric motor, of course, that's what's going to drive the whole thing. And then, of course, we need a way to charge it from the outside. So we're going to have a charging port and all the accoutrements that go with that. We also need to remember safety first. Safety first, last, and always. So it is a high voltage system. Can be, most of them are 300-400 volts. And that's going to hurt. So a high voltage system may remain powered up for up to 10 minutes after the vehicle is shut off or disabled. To prevent serious injury or death from severe burns or electric shock, avoid touching, cutting, or opening any orange high voltage power cable or high voltage component. You also have to make sure you take out the plug. There's a plug you need to take out there. A couple people have mentioned when I've talked about this before that what they do like a lockout tag out type of thing, where they'll just do like a lockout from electrical panel type deal going on. So they'll just pull it and tag it. Sometimes they'll just make the tech put the plug in the pocket, so they don't have somebody else just randomly plug it in by accident. And that could hurt. That could kill somebody. So we don't want to do that. By the way, while we're on this note, in the United States, there are this many requirements, this many licenses that need to be had in order to work on an EV. Now, over in Europe, it's a little bit different. They have, extensive training courses they have to go through, and they have licensure and whatnot that they need. So if you're watching this in the United States, I would strongly suggest getting some further training, more than just this kind of overview that I'm giving here. There are ways out there. I've seen companies like iCar is one of them, I think, offers a pretty comprehensive course on how to do it. So if you want to really get into this, I would strongly suggest getting further training on it. And of course, if you're watching over in UK, Europe area, of course, you need to get your certifications before you can even do that. So just so you're aware, things are a little bit different on either side of the pond there, right? So um, the battery, which is going to be the main culprit of any of those issues. Multiple small low voltage batteries linked in series. So they're a bunch of 3-ish volt batteries just kind of tied together with a bus bar. And it gets you high DC voltage in a 300 to 400 volt range. Most manufacturers don't go over 400, but I'm sure there's probably a couple out there. They're usually nickel metal hydride or lithium ion, and they are large packs and quite heavy. Like I said, we're going to see a comparison a little bit later between what you might find in a hybrid. There's special lifts for it in order to take it out of the vehicle, and they just weigh a ton. There are shops out there now that have gotten into the business of rebuilding these as well. So you get a couple bad battery cells, you can dismantle the pack, pull a couple cells out, clean up some stuff, put some new cells in, balance the battery, and you have basically a reman or refurb battery. So there's a lot of companies out there doing that right now, since there are so many EVs out there. And then the battery, the battery cells can be had by themselves in places. Battery heating and cooling, they must be cooled to maximize performance in life, or they must be warmed up depending on temperature outside. So 3 methods are used. Passive air cooling's not as common. That's just kind of using air ducts from the outside of the vehicle as it drives down the road. It just, the outside air goes over it. Active air cooling, which would be fans, and then liquid cooling, which would be using coolant. So in this example, it looks like a e-tron, Audi e-tron, and it has, you can see where the coolant passages are, with the battery, so cooling and heating it. So liquid cooling seems to be popular among a fair number of manufacturers. Like I said, liquid cooling can also warm the battery if needed. Coolant must contain deionized water because it is going near electricity. So if we have non-deionized water, it may have stuff in there where it can carry an electrical charge, and that would be bad. So we got to make sure it's deionized water. And the coolant would be either warmed or chilled depending on the need, and it uses an electric water pump. And it also has a radiator, just like an internal combustion engine vehicle. So it's got a battery chiller here, and it also has a heater here. So it just kind of depends on which way it needs to go. It'll open the valves and then heat it or cool it, depending. Converter or inverter is going to convert AC to DC. It also converts high voltage to 12 volts for the low voltage system in some cases. Reverses the step up to charge the battery while braking as well. So if it sees, a reverse charge going back to the battery, it allows it back into the battery to charge it up. Here's just another example where you might see that. So the power control unit, high voltage junction box, the battery goes into there at 360 volts. Then the low side comes out at 12 volts. And then we also have some other battery management system, brake switch, shift levers and stuff go into the vehicle control unit. And it just kind of controls how everything goes back and forth. Regenerative braking system that transfers energy from braking to charge the battery. So that uses the electric motor to brake. So basically when you let off the accelerator, it'll go into kind of a decel engine brake type deal. And in that mode, the motor becomes a generator at that point. Still does have hydraulic brakes to use, but I will say this. I've driven a few hybrid vehicles. I've driven 1 or 2 electric vehicles, and the only one that I've ever driven that as soon as I drove it and I let off the accelerator pedal and it went like it was like losing power or shutting off or something because of that regen function, was a Tesla. I'm like, I am never going to buy one of these. I was kind of thinking about it at the time. If I was ever going to buy an EV, that would probably be the one I'd get. But yeah, that turned me right off right there. The way they handled the regenerative braking was just like it almost brought the car to a full stop in feet. Like, this is a little aggressive, I think. Other vehicles that have driven like that, you barely even tell what's going on. Because, like maybe coast downhill or something, or just coast on a straight road. And sometimes if you let it off, it'll just go into that regen. Did not like that at all. That's just me. Maybe you're fine with it. And I know there's other reasons other people, people wouldn't buy electric cars, but that's not what we're here to discuss. So, yes. That was the one thing that turned me off on that anyways. And then we have the electric motor. It's going to be high AC voltage, 4 or 500 volts, used to drive the wheels and used to charge the battery during regenerative braking. Like I said, it basically just runs in reverse. And most are a 3-phase AC motor that you're going to find out there. So going to work kind of like on the same lines as the DC brushless motors, like in a brushless fuel pump type of deal, where the stator has the windings and the magnet turns in the interior. Like this. There's the windings, there's the magnets, right? So the turn uses those to turn, gives us a nice amount of torque, and it also has the 3-phase in there, but we also need something to know where it is rotationally so we can turn these magnets on and off the push and pull turn the electromagnets on and off to push and pull the permanent magnets. So you're going to see that right here. That's the resolver, and you do need to go in and relearn it sometimes or initialize it, reset it if you do any work in there on the electric motor. So just be aware of that. There is a scan tool function. We'll look at it a little bit. So just here's an example on the it's the 3-phase AC. So you have the UV and the W, and that's the motor control unit. Spits it out to the actual traction motor itself, and then you see we have resolver positive and negative, and then we have 4 other motor resolvers there, signal wires. So 4 signal wires on that. So that's all involved inside the motor itself. And we'll talk about that more in a little bit. And then on these vehicles, they really don't have a transmission to speak of. It's more of a reduction gear set. So it changes the motor speed and the torque. Going through this is going to reduce the rotational speed. And in that opposite of that, it's going to increase the torque. So when torque goes down, speed goes up, speed goes down, torque goes up. All right, so it's got a reduction gear in there. And then you can kind of see where it's the cross section comes in here. We got a couple gear sets in there, and then we have where the wheels, where the output shafts to the wheels would go out there through a differential. So it's like a very small transmission, but it's not changing gears. It's just kind of go and not go. And of course, the high voltage battery needs to be charged. So we need a charging port and systems to support that. So home chargers and charging stations can be used depending on what you got. And regenerative braking, like I said, also provides some charge, but not a ton. I'd imagine maybe if I was on like in the Rocky Mountains and coasting down the hill. In that case, yeah, I would be doing a lot of regenerative braking, so maybe I might get a fair amount of charge out of it. But just by slowing down, it's negligible how much it gives back. We also have normal charging or quick charging, so there's systems in place to handle that. So normal charging, like stay out of your house, would just go through the regular onboard charger and then go to the battery. Otherwise, the quick charging has got a couple relays in this case that would close and then provide it straight to the high voltage battery there. So a couple different ways it goes about it. It uses a junction block in this case. So we have the 2 relays for the quick charge. Quick charge comes in here, and then it goes out to the 2 through a bus bar to the 2 relays. And then if it goes out of the relay, then it'll go up to the battery. As far as diagnostics is concerned, due to the complex electronics, diagnosis is usually with a scanner. Usually if you walk through the flow charts from the manufacturers, it's going to be, you got to do this test and look at these PIDs and make sure the value is XYZ, make sure the difference in between the battery cells is less than 0.3 volts, that sort of thing. So a lot of your diagnostics is going to be done sitting in the car with a scan tool. High voltages require caution, of course, working on many components. 12-volt systems can be diagnosed like any other vehicle. So your radio, your blower motor, maybe your seats, your windows, your door locks, all that, windshield wipers, all that other stuff works on 12 volts. So it's going to be the same diagnostic flow as you would get with just a regular car with 12 volts. So just keep that in mind too. Oh, just because it's a hybrid or electric vehicle doesn't mean it doesn't have a million other 12-volt components on it. And that brings us to component testing. Same rules apply. Due to the complex electronics, it's usually with a scanner. High voltage require caution. 12-volt system can be diagnosed like any other vehicle, and most high voltage systems are not suitable to test with an automotive scope. There are some things in the systems that we can test, and we'll take a look at it in a little bit. When it comes to like water pumps and things like that, we can diagnose using a scope. We actually have a guided component test section on that in there. So that brings us to hybrid vehicles. And you may notice on this cutaway of a hybrid vehicle, that battery is tiny compared to the battery in that electric vehicle. So we're going to find we have 3 different sizes of battery. So this is a Toyota here. Looks like it's probably an all-wheel drive Toyota because there's a motor in the back as well. So it's got a motor for the rear wheels, motor for the front wheels, and then the gas engine, of course. And then we have the small battery, and then this is going to be all the power pack and the generator and all that we're going to talk about. So there's different powertrain types out there. The most common one you're going to find, at least early on in the hybrid world, I think they're moving more towards plug-in, but parallel is the most common design out there. Gas and electric motors are linked to a common transmission, if you want to call it that. It's not really a transmission. It's more like that gear reduction motor again, because the motor itself doesn't go through a transmission, so it just does that. Generator and motor are generally grouped in there where the transmission would be, right? So on a normal, non-hybrid, non-hybrid, non-EV vehicle, you're going to have, your clutch and or your the transmission stuff, torque converter. There we go. Maybe clutch, torque converter, what have you, and then just whatever's left over in your transmission in there. So the transmissions are, if you want to call it that, it's a little bit different when it comes to hybrids and EVs. They also have series design, which is very uncommon. I think it's really only on like a couple BMWs, the I series with the extended range. The electric motor drives the vehicle exclusively, and the gas engine is used only to charge the high voltage battery, nothing else. It doesn't have any connection to drive the vehicle at all. It's just to help extend the range as it charges the battery, hence the extended range part. And then plug-in hybrids. Those are becoming a lot more common nowadays, and this is kind of more of a cross between a early hybrid vehicle and a true EV. So it's kind of a midway in between. The battery's a little bit bigger. Gas and electric motors linked to a common transmission, or diesel, I suppose. Generator and motor are generally grouped in the transmission assembly like before. Larger battery with greater range, and the internal combustion engine is used only under high load conditions, so maybe going up a hill or something like that. The original early ones, like in the Chrysler Pacifica plug-in hybrids, they said if you were just putting around town going to get groceries and stuff like that, that internal combustion engine may never turn on because you got enough battery range, and then you just plug it in at night. So it's an EV around town, and then when you go on the highway maybe or something like that, the engine might turn on. It's going to have very similar components to what we have in the EV, except for it has the internal combustion engine there. So internal combustion engine, battery cooling and heating system, generator, voltage converter, regenerative braking system, and the electric motor itself. The battery is smaller, and it has multiple small low voltage batteries linked in series, which gives us 300 to 400 volts. Nickel metal hydride or lithium ion. Often smaller than an EV. Like I said, that's small enough to fit under the rear seat. And speaking of which, I just found this today in Car and Driver. I found a little article on this. They were comparing different systems across Ford. Right, so Ford has an F-150 hybrid, an Escape plug-in hybrid, and of course the Mustang Mach-E is full EV. So if we look down here, the hybrid has 76 cells, 20 watt hours per cell, and it weighs 77 pounds. The battery pack takes up 1.2 cubic feet. So 1.9 kilowatt hours per 100 pounds is what that output is. Kind of a weak battery. Then we get in the middle here, 364 pounds on this battery, 3.9 cubic feet, 300 volts, 84 cells at 171 watt hours per cell, which gives us 4 kilowatt hours per 100 pounds, which is better. And then we get the full extended range. This is probably I believe this is their biggest battery they would have for the EV. 1,323 pounds, weighs more than half a ton. 16.2 cubic feet, so that takes up most of the undercarriage of the vehicle. 343 volts, 376 cells, and gives us 262 watt hours per cell, which is 7.5 kilowatt hours per 100 pounds of battery. So that's a lot of energy parked in that giant battery. That's why we get that extended range. But that just kind of gives you the lowdown on different sizes, right? So if it's just a straight hybrid, it's going to be mostly engine, and then the electric kind of as a backup, and then the plug-in electric gets more of a dual use. And then the full EV is going to be a lot different. I want to look up that battery a little bit. The generator is kind of there in the middle. It's used by the engine to charge the battery. It's also used to start the engine. So they send a command. It goes in the opposite direction, or it'll send a command to spin the generator, which will spin the engine. So there's not a traditional starter in these. They use the generator in reverse basically to start the engine, and it outputs an AC voltage. So if we take a look, we get the generator there, which goes into the inverter, and then it comes back out to the motor. These are AC three-phase there. So we got 200 volts coming out, 200 volts to the AC compressor, 12 volts over there. So you can see how that inverter converter kind of just splits out the DCs and the ACs and all that. And then regenerative braking system, as we said earlier, transfers engine from energy from braking to charge the battery, uses the electric motor to brake, and then the motor runs in reverse basically. The hydraulics are still used. Hydraulic brakes are still used. Then the electric motor is a high voltage, 400 volts or so, used to drive the wheels, used to charge the battery during regenerative braking, and most are a brushless type DC motor. Now let's talk power flow. So on, I forget what car I was on. I think it was a Toyota, or maybe it was a Hyundai. They have a diagram. Actually, most of them probably do, but I have a diagram on the driver information center to tell you what's going on in the vehicle. So in full electric mode, comes out of the battery, powers the electric motor, which powers the wheel. In hybrid mode, the engine is powering the wheels as well as the electric motor. So that's kind of your twofer. And then engine only mode, the engine is going to power the wheels. In charging mode, the engine can drive the wheels and then charge the battery, or the engine can charge the battery while the electric motor drives the wheels. That works too. And I think that's the same. Yeah, that's actually the same shot next to each other. So yeah, that's going to charge the battery while it spins, electric motor spins the wheels. We also have regenerative going back to the engine, I guess, using the engine as a brake, and then it charges the motor, and then also charging off the wheels back to the battery. Idle mode, nothing's going to be happening because we're just going to be sitting there. Engine braking, once again, the power goes back to the engine from the wheels, and then charging without driving, the engine can run charging the battery. So this is probably I don't know, one of the least likely scenarios. But tells you all the different options on the screen on the car, so you know what's going on. All right, let's go live on the tool. Take a look at a couple vehicles. First thing I said, I wanted to look up that Mach-E because probably a 2023 data, right? Staying Mach-E premium, I guess. I just want to see out of my own curiosity. Call it all-wheel drive too. Why not? That's probably got the bigger HV battery. Do we have parts and labor? Yes, we do. All right, so the battery, 6.5 hours to remove and replace. All-wheel drive, high voltage with extended range, $34,000 from the dealer. That's crazy. Like I said, it weighs more than half a ton, so yeah, I guess that tracks. That certainly tracks. All right, I have a couple other different vehicles I want to look at. Let's Toyota Highlander, just all-wheel drive, so it's got a front and rear electric motor, like the one we saw in the diagram. So of course it is a hybrid, so we're going to get your engine stuff up here as well. If I come and remember, you're still going to have your ADAS stuff, anti-theft, body controls, all that stuff runs off 12 volts. To get to the hybrid stuff, we'll come down here to hybrid and electric vehicle, hybrid control. We're going to have some actuator tests in here, battery cooling fan, water pump. You may need to do that in order to bleed the cooling system as well to activate the water pump. Activate the hybrid and EV battery water pump. Different solenoids and such, radiator fans. Those are usually your on-off controls, the actuator test. Routine tests, we're going to have a compression test for the engine, hybrid battery charge. This will actually put it into a charge mode. So if it's dead, and you need to charge it, so there's a special high voltage battery charger for it. And then we would hit continue. And that says initiates charging from the THS HV battery charger. Hybrid battery charge activation status can be found on the data list right there. And light status of the battery charger. After the test is finished, turn the ignition switch off. Active tests cannot equalize the voltage difference of battery cells, though. Hybrid battery charge, current value changes following the condition. So that's just going to give you a value. You'd hit start and it would charge. Sometimes you need to do that if it is dead. Customize different settings and body control. And then special functions. So battery status information update. So if I do anything with the battery, I need to update the computer to know that. High voltage fuse accumulated load history, growth shutter initialization, EV mode cruising range reset, AT code registration, ACT position learning. So this is for the SPW ACT, I guess. And then it would go through and just do a relearn. And of course, I'm in sim mode, so that's not going to work. What else we got? Motor generator. That's going to have a couple actuator tests for the inverter cooling fan. I guess just one. Routine tests control the oil pump. And then system tests will be resolver learning and initialization. So we talked about that earlier, the motor resolver. It's kind of like a crank position sensor, I guess, if you want to call it, or an output speed sensor. So it knows where it is in rotational space, so it knows how to control it. So it's used to learn and initialize the correction amount for resolver variations, to execute relearning of the resolver when parts are replaced, for a repair manual and to use this function. So you go in there, you can either do an initialization or a learning. I'm going to get an error if I do either of those because I'm in a sim mode, but I actually get one right there as well. So, but that is, if I was hooked up to a car, it would work. And then we have the rear motor generator, which is going to be the same, very similar anyways, resolver, cooling oil pump, etc. So also with these, some manufacturers, some vehicle, hybrid or electric, we're going to have one that says hybrid electronic. And things like the cooling system pump. So I can go in there and there's my plug, what it looks like, and then electrically driven water pump, circulate cooling water through the inverter assembly. It's going to tell you a little bit more information about it. And then I can do a voltage test, checking for 12 volts. And then I can also do a signature test because it looks like it's pulse width modulated. So you're going to see the different duty cycles on that as well. So yeah, water pump signal. So there are tests. The rest of these are like warnings and descriptions of things like inspection mode, safety gloves, auxiliary battery, talk about that. The service plug, like I said, that's often good to keep in your pocket because you got to remove it. And then any abbreviations used in here, nice to have. So that's the Highlander. Let's go into the Nero. Kia Niro, this one should be a hybrid as well. Danger, high voltage, be careful. Yeah, so it's got engine transmission, so this is a hybrid. Come down here to hybrid electric, we got battery management system. And you're going to have, on it, pretty much any of the battery management systems, you're going to have like all your different cell voltages, and you want to make sure they're fairly close, within a couple tenths of a volt. Otherwise, one of the batteries might be going bad, one of the cells might be going bad. So different, like this one has a battery cell voltage deviation. All of this stuff's going to be nonsense in this mode just because it's a simulator, right? So it just throws random numbers. Functional tests, got a bunch of fans, so you're cooling the battery and stuff. Main relays, 12-volt latch relays. System tests, inspection of the 12-volt battery, state of charge on the battery, calibration, and isolation breakdown detection function to see if any of the isolation in the battery pack is breaking down. There's a test for that. Insulation resistance of the high voltage parts as well. So those are important tests to have to check for any failures. Hybrid electric control unit. It's going to engine clutch. And there's another motor resolver learning there. So that tells you how to do it. State of charge over 35%. Placing dual clutch transmission, drive motor, engine clutch, and actuator. Following functions must be performed. Initialization of the engine clutch inspection line learning. Removal of air from the engine clutch hydraulic pressure line. Electric clutch and motor resolver adaptation. So we need to do an adaptation after that. So it would go through the process once again. Sim mode doesn't go all the way through it. Also variant coding on there. Changing specifications when changing the module. So different things that you might need there. That's going to error out as well. And then, yeah, this one doesn't have guided component tests. Okay. And then we'll go to the Kona. That's an EV, straight EV. Danger high voltage. See no engine or transmission listed, so we know it's a full EV. Motor control unit. Run the radiator fan. Electric water pump control. You need to do this to bleed out the air in the system as well. So you'd walk through there. Anytime you do any repairs on the coolant, you need to do this, and that's going to take 3 minutes to go through. And then once it's done, it'll say it's done. I'm just going to exit prematurely because we don't need to wait 3 minutes. But I will walk you through it. Let's see. And then the battery management system. Some Hyundais and Kias, not all of them, and a couple other manufacturers we've added recently as well, have a full high voltage battery health check that you can perform on. It's like an automated functional test that we designed. So you go in there, we'll check the health of the high voltage battery. Do I want to continue? Sure. First one's going to be state of charge of the battery system, and then what the status of health is. It should be 100% if it's fully healthy. And then you just kind of read that out. You could print it out if you wanted to, or save it, and then hit continue. And of course, this time it's going to give me a fail because they were both at 0. They should have some sort of state of charge if they were healthy. And then next screen is going to give us the max cell voltage and the minimum cell voltage. Remember, it should only be a couple tenths off. And then the max cell voltage number, whichever cell had the max voltage and which had the minimum. So if it was like a volt difference, you can go and take a look at, hey, this is the cell that I need to take a look at. And of course, you might want to look at the full data lists in order to see, okay, so I know cell 33 was the lowest and it was like a volt lower, but how does that compare to a couple other cells in the neighborhood, right? You want to look at all the different data together. And that's usually in the battery management system for that. Motor control unit, it's going to have a lot of the same stuff. Run the fan, water pump to bleed the coolant. I don't know if this one has good component tests. Let's see. No, the electric vehicle is not listed, so that one doesn't have it either. And then lastly, a Tesla, because we did add this recently, fairly recently in the fall. So with these, we go down to hybrid electric vehicles, and there's, of course, a ton of stuff because it is a purpose-built electric vehicle. They don't necessarily have to follow the same commonalities that a traditional manufacturer with internal combustion engines wouldn't necessarily follow. And their operating systems on their computers are totally different. So they run things a little bit different. So let's say if I went on the battery management system, things like clear contactors, reset these different codes, error codes that would come up. So as you go through and diagnose the vehicle, if you go through their repair information, which a lot of it is free, by the way, through them, if you go through repair information, it might say, oh yeah, go through and then hit this reset, and then it'll reset the problem, and that should be good. You can do a hard reset as well. It's kind of like you're unplugging it and plugging it back in again type of thing. So a lot of their computer modules on their vehicles work that way, where it's like a reset, a hard reset, soft reset, that sort of thing. You can see, ADAS and all the other doors and windows and the normal stuff you'd expect to find, but there's a ton of different stuff running that EV. Right. And then, of course, on Tesla, we also have guided component tests. It's going to be only on the ABS system at the moment. With things like the module, the pedal sensor, wheel speed sensors, brake fluid, yaw rate sensors, parking brake actuators, etc. So a lot of good coverage in there, especially on that guided component test. No, you're not going to find that anywhere else. All right, so that is our hybrid and EV refresher course. Like I said, if you really want to get into this, find a new profit center in the shop or something like that, I would strongly recommend taking a few courses on it. More in-depth courses, maybe ones where it's a few hours at least, maybe a day or two, just so you can get your head better wrapped around it and understand how it all works. Maybe even hands-on some classes are. Like I said iCar, I've seen people in iCar class and they're hands-on with a battery, dropping it out of the vehicle. So They can be had. You might have to travel, but sometimes training's worth it. So something to consider. So like I said, that is hybrid and EV for today. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week and we'll see you on any of our other videos. Have a good week, have a good night, and take care.